Okay guys, welcome back. So the title for today's notes is going to be the unit circle. And instead of me just telling you this is the unit circle, believe me, it would be better if we developed together the idea of the unit circle organically. So you're encouraged to write this down. Here is just the general idea and the general development of the unit circle. So why don't we draw, as it were, the first quadrant. And let's place a point just randomly here in the first quadrant. And let's call the coordinates x and y. Now, can we agree that this component here, the horizontal component, would have a length of x, and that the vertical component here would have a height or a length of y? And what we can now construct here is a right triangle that looks like this. We can go like this here, sideways, and we can stop and go upwards toward the sky, and then we can connect it to the origin, so that we have a right triangle with all the typical markings, this being the 90-degree right angle, and this being our angle theta in standard position. Now, the general idea behind the unit circle is this. So we fix the hypotenuse. We fix the hypotenuse to have a length of 1. So this is the underlying premise behind all of this set of notes, that the hypotenuse must have a length of 1. So what we can do in our hypotenuse is label it 1. It has a length of 1. We could even label the 3 sides like we've been doing lately. This is the hypotenuse. Across from theta is the opposite, meaning that the remaining side is the adjacent. And this discussion we've had lately of sine, cosine, and tangent, maybe we can consider those ideas now. Sine of theta is, well, remember your cheat sheet. Sine is opposite over hypotenuse. Well, the opposite is going to be this, which is y, and the hypotenuse is 1. So sine of theta would be y over 1, but the hypotenuse 1, y divided by 1 is just y. Hey, what about cosine? Cosine is, even a little cheat sheet, cosine is adjacent over hypotenuse. So our adjacent is x, hypotenuse is 1. Hey, x divided by 1 is just x. And what about tangent? Tangent of theta, tangent is opposite over adjacent. So the opposite is y and the adjacent is x. So it's just y over x. And when we say, like, when we're talking about this y and this x and this x and this y, we're referring to the coordinates of that random point that was placed there. Now, some of you might be thinking, what does this have to do with the unit circle? I don't see a circle anywhere here, Mr. Lee. Well, here's what we can do now. What we'll do, I'll try to do it in a different color, maybe like orange. So what we're going to do is, I want to draw a circle that the middle of the circle is here, that's the center, but the circle passes through this point. So I don't know if I can draw the whole thing, but that's the general idea. There's a circle that goes around where the center of the circle is here, and it passes through this point. Now, you see this hypotenuse here. The hypotenuse has a length of 1. But what I want you to think about, guys, is instead of the triangle, think about the circle, okay? Think about the orange circle. If we're talking about the circle, then this thingamajig here, this would no longer be referred to as the hypotenuse, would it? It wouldn't. The vocabulary hypotenuse is with respect to the red triangle. But if we're talking about the circle, then this thing here, this line segment, instead of calling it the hypotenuse, you'd call it the radius, right? The radius, you've heard of that word before. And the radius has a length of 1. Now, in any math class, in any classroom in the world, the word unit means 1. Unit is 1. And that's why it's very appropriate to call this circle the unit circle, because the radius is 1. So that's the unit circle. It's a circle with the radius of 1 that goes around the middle and that has all these properties. So this is just a general idea. Let's actually formalize this. So here are some facts. So maybe you copied down all of this. If you didn't, definitely go pencils up now. So here are some facts. On the unit circle, comma, we have the following. So this is gold here. So on the unit circle, we have the following properties. So here we go. Sine of theta, cosine of theta, tangent of theta, leave a little bit of space, cosecant of theta, secant of theta, and cotangent of theta. So if we are operating on the unit circle, then the following holds true. Sine of theta would just be the y-coordinate of the point. Cosine of theta would be the x-coordinate of the point. Tangent of theta would be the ratio y over x. And now that you have the first column, you know that the reciprocal functions are just the reciprocals of these items. So for instance, cosecant would be 1 over the y-coordinate. Secant would be 1 over x. And similarly, cotangent of theta would be x over y. And if you actually, guys, if you look at your cheat sheet, that what we just wrote, it's been actually there the whole time. It's just now we understand where these things came from. So let's use these facts to do a handful of problems here this afternoon, and then you guys can try the attached homework. So these facts, we're going to use them, and so what you're going to need now for the rest of today is for sure this guy here, the trig identities if you want, but really more importantly, you're going to need this, the unit circle. So I did attach this to the assignment, so you want to download one of these, print it out if you can. So with that in mind, let's try several problems here this afternoon, beginning with this one here. And the directions are the same for all of these, and that is evaluate. So let's, example A, let's start like this. Sine parentheses 240 degrees. So here's what we want to do. Here's how I think about it. What I do is, so here's me giving you the lesson in a summary. What you do is, you go here and you give them that. I'll say it again. You go here and you give them that. So let's try to apply this. So let's go to 240. So bust out the unit circle, and 240 is going to be right here. I'll even turn the paper sideways a little bit. So 240 is right there. So I know where I go. I go right here. But now that I'm there, what do I give them? I give them sine. What did we say sine was? Sine is just the y-coordinate. Well, at this location, what's the y-coordinate? That's the y-coordinate because it's x and y. And so this would be the answer. Negative square root 3 over 2. Done. Maybe I should just quickly tell you about the unit circle, right? After all, that's the title of this notes. Look, the unit circle is loaded with information. And look, for instance, at any specific location, you have the angle measure in degrees and radians. And then you also have a point with the coordinates. That's the x and that's the y coordinate. So that happens at many of these locations on the unit circle. Degrees, radians, x and y coordinates. That happens for all these locations here. So that's how we did example A. We went there and we gave them sine, where sine was just the y coordinate, which was that there. Let's try a few more so you guys get really, really comfortable with this. So for part B, what about this? The cosine of 3 pi over 4. So let's identify 3 pi over 4 on the unit circle. So look around and 3 pi over 4. I see it's right there. Let me turn it sideways a little bit. So I know that I'm here somewhere. 3 pi over 4. So I'm looking at these coordinates. Now they want from us cosine. And then based on your definitions, based on your notes, cosine is just the x coordinate. Well, at that location, at 3 pi over 4, the x coordinate is negative square root 2 over 2. Done. Now this concept does get more interesting now, so let's not, be in a hurry here, because this can get a little more interesting. What about part C? The tangent of 330 degrees. Okay, so let's go to 330 here on the unit circle. 330 is, so it's over there. So those are the coordinates. Now what's with tangent? Tangent is, look at your notes. Tangent is the y divided by the x. So it's the y coordinate divided by the x coordinate. That's what tangent is. It's the y over the x. And then cosine was just the x coordinate. So let's see. Go to 330, which is here. And then we said y divided by x. So it's going to be that divided by that. So literally go negative 1/2 divided by that. So that would say negative 1/2 divided by square root 3/2. And then what you want to do is for something like that, please use your calculator to do this algebra. If you tap it into your Casio, I'll let you try it to verify. But it should be negative square root 3/3. The calculator will do this simplification for you. That's what it should be. But you should really try to get used to that. Try that on your Casio to make sure that this gave you that. Okay, let's try a few more, then we'll call it a day. So how about part D? So for that one, let's go with this. Let's go with the secant of 5 pi over 6. So we look for 5 pi over 6, and it looks like it's right there. So I'm looking at these guys. But then secant, look at your notes, your cheat sheet. Secant is 1 over x. So secant is 1 over the x coordinate. So there's 1 over. Now the x coordinate at 5 pi over 6 was negative square root 3/2. That's kind of weird, but let's see. Negative square root 3/2. And again, at this point there, for something like that, type that into your calculator. You know what I mean? Just type that into your calculator. And if you do that, it should say negative 2 square root 3/3. So do the best that you can to not use the calculator until you get something like this, right? So that's part D, final answer. Now let's try a couple more. Let's do 2 more, and then I'll be okay. I'll stop in there for today. So for part E, up here now, how about we look at the cosecant of 270 degrees. So let's see, handy dandy unit circle. 270 is, well, that's interesting. It's along one of the axes. So this is 270 here. Those are the coordinates. Now, what did they want? They wanted cosecant. Let's see, I already forgot. Cosecant is 1 over y. So cosecant is 1 over the y. Well, what was the y coordinate there? The y coordinate was negative 1. So 1 over the y coordinate, well, that would just be negative 1. Hey, by the way, if the problem had been like 1 over 0, it would have been undefined. Anytime you find yourself trying to divide by 0, it would be undefined. Until you get to calculus when they talk about what it means to divide by 0. So anyways, let's try one more, and then maybe this one will give us the ability to have a quick little discussion. So the last one for today says this: the cotangent of negative 240 degrees. You see, I saved this for last because this one's a little different. You see, the unit circle, it goes from 0 to 360. It's positive, but this is negative. So I know that I'm supposed to go here, but I don't know where that is. Now, don't be fooled. It's not necessarily 240 because like that says negative 240. It's completely different. So here is just a general philosophy. So you can go pencils down for like 1 minute. Let me just explain this. Let me just grab, let's say like this red pen, and let me point it just randomly like at this little thingy-majig here on my table. I think that was like some old paint from one of the custom shoes I was making. Look, so the pen is pointing at this old paint mark. Now, what happens if I take that pen and I turn it 360 degrees? Look, if I turn it 360, what's going to happen? It's going to be pointing exactly where it was before. Nothing changed. So the point is, you can add 360 or subtract 360, whatever you want. You can do 360 anytime you want, as many times as you want. You know what's going to happen? You're going to be pointing exactly in the same direction as you were before. So what I'm saying is this, that negative 240, I just do some quick scratch work. If I take negative 240, if I add 360, I get 120. And I prefer this because 120, I can see it on the unit circle. It's like right there. So anytime you have a number that you don't like, add 360 as many times as you want to, or subtract 360, whatever. Just get back something that you know is on the unit circle. And by the way, these are called co-terminal angles. So let's finish this problem. So what we're saying is that this problem, it might as well have just said cotangent of 120, because that and that point in the same direction, except this I don't like, this I do like, because I know where that is. That's right here. And now let's finish this problem. So I know where to go. 120 is right there. Cotangent. What was cotangent again? Look at your notes. Cotangent was x over y. Cotangent is x over y. And so at 120 degrees, x over y, you go that over that. And that would be negative 1/2 over, as it said, square root 3 over 2. And again, please go calculator at that point there. And it will say negative square root 3 over 3.